MBA633 instructional video prepared by Professor Amit Datta, School of Management, George Mason University. In this segment, we'll discuss how to develop a confidence interval for a population proportion. So the problem setting is the following. In a survey, 200 people were asked to identify their major source of news information, and 110 of them stated that the major source was television news. So we are to construct a 95% confidence interval for the proportion of people in the population who consider television as their major source of news information. So we know from our discussion of confidence intervals that what we are looking to develop here is a range. So I want to develop a lower limit and an upper limit such that I'm 95% sure that the true but unknown population proportion lies within that range. So in terms of the sample statistics, so the population here is the set of all people, and we are asked what proportion of them consider TV their major source, news source, and the sample size is 200, and out of those 200, 110 say that they consider television their major source of news. So the sample proportion is 110 divided by 200, which is 0.55. So this figure of 0.55 is our point estimate of the population proportion. So if I had to give you one number which is my best estimate of the population proportion, it would be 0.55. But I want to go beyond that, be a little more sophisticated about it. I want to develop a range, a lower limit and an upper limit, such that I'm 95% sure that this unknown proportion lies within that range. Now we know from our central limit theorem that if the sample is large enough, then the sample proportion is normally distributed. So we first have to check that the sample is large, and there are two calculations that we have to do as we discussed in class. N times P bar must be greater than or equal to 5. N times 1 minus P bar must also be greater than or equal to 5. So in this case, that would mean 200 times 0.55, which is certainly greater than or equal to 5. And the second test here would be 200 multiplied by 0.45, which is also greater than 5. So it very clearly both these tests are met. Hence, we can conclude that the sample proportion is normally distributed with the mean of P, which is the unknown parameter that I'm trying to estimate. And the standard deviation of the sample proportion is given by the square root of P bar times 1 minus P bar divided by N. Okay, and that's the standard deviation of the sample proportion, which comes to 0.55 times 0.45 divided by 200. And you take the square root of that and you get 0.035. So that's the standard deviation of this sample proportion. Now, if I want to be 95% sure, that this basically means that my margin of error, this quantity over here, this width over here, has to be large enough so that this area under the this yellow shaded area under the curve is 95%. So you know how Excel works. So I would use the norm inverse function, norm S inverse of 0.975. Now why 0.975? You recall Excel needs the norm S inverse function needs the complete area to the left of the position on the x-axis that you want to find. So since the middle area, the yellow shaded portion, is 95%, the tail, the left side tail over here is 0.025, 2.5%. And that's why I have input 0.975, which would turn out to be 1.96. If you plug it into that built-in function, you will find 1.96. So our interpretation is that if I want to be 95% sure, my margin of error has to be 1.96 standard deviations large. Therefore, for this specific problem, the margin of error would be 1.96 multiplied by 0.035. Why? Because one standard deviation is 0.035. This is what we just calculated a minute ago. Okay, so this is approximately equal to 0.07. Okay, so that's how much the margin of error is in this case. Hence, I am 95% sure that P, the population proportion, lies between 55%, which is the sample statistic, so 0.55, plus or minus 7%. Okay, so in other words, between 42%, let me see if I, between 48% and 52%. So 55% plus or minus 7%. So that is between 48% or 52%. So the end result of our calculations is that I am 95% sure, based on the sample statistic and the sample size that I have, I am 95% sure that the true population proportion, in other words, the proportion of people in the population who consider television as the major source of news information, that true proportion lies between 48% and 62. I'm sorry, it's not 52, 62%. So I am 95% sure that P lies between 48% and 62%. So that's how you compute the confidence interval for a population proportion, and the basis for that calculation is that if the sample is large, then the sample proportion, in other words the sample statistic in this case, is normally distributed with a mean of P and a standard deviation of P bar times 1 minus P bar divided by n, square root of that. Okay.